Hello, this is Mr. Stansbury. I'm going to take you through the notes on division by surds. At the end of this, you should be able to say I can rationalize the denominator using surds. All right, so with that, to rationalize the denominator is basically to get rid of all the irrational numbers in the denominator. Okay, so we can't have roots in the denominator is basically why we have to rationalize the denominator. For any fraction of the form b over the square root of a, we can rationalize the denominator by multiplying by root a over root a. So basically, what do we have to multiply this down here by to get it so that it doesn't have a root anymore? So since this is a square root, square a times a is going to be a squared, right? So if we do, if we do root a times root a, that's going to give us the square root of a squared, and then this square and the root will turn this into a, and we then no longer have a root in the denominator. All right, let's try some out. Write with an integer denominator, which is rationalize the denominator. So to get rid of that root 3, this is the square root of 3, so if we multiply that by another root 3, and if we put the denominator as root 3, we've got to make the top as root 3, because anything over itself is equal to 1. And you can multiply anything by 1 and not change it. So 2 times root 3 in the top is just 2 root 3. And then if you'll notice on the bottom, root 3 times root 3 is root 9, which is the same thing as 2 root 3. Square root of 9 is 3. And we have rationalized the denominator. Or we also have written the denominator with an integer. Okay, same thing over here. 15 over root 5. We're going to want to multiply by root 5 over root 5. The 15 root 5 gives us 15 root 5. 15 times root 5, sorry. Root 5 times root 5 is the square root of 25, which we hopefully know as 5. So we have 15 root 5 over 5. Now these two, like 15 and 5, we can divide those. We can divide that nicely. So let's do that. 15 divided by 5 is 3. So we just end up with 3 root 5. Okay, 15 over 5. Those will play together nicely. All right. For any fraction of the form c over a plus root b, we can remove the surd from the denominator by multiplying by the radical conjugate, it's called, which in this case is a minus root b over a minus root b. So basically what you do is you just find the radical in the denominator, and you want to, if there's two different, two terms down there, you want to switch the sign of whatever's in front of the root. Okay, so let's try one of those right after we take a look at a little comedy clip. Yeah, you just don't see that every day, a cat chasing a dog. But anyway, with example 8, write the following with an integer denominator. So this is where we got to do our rationalize our denominator. So what we got to do here is we got to multiply this by the conjugate. So it's 2 minus root 6, so we're going to do 2 plus root 6. And 2 plus root 6 here also. So 4 times 2 root 6 and 2 minus 2 root 6 times 2 root 6. So on the top, 4 times 2 is 8. 8 times root 6. 4 times root 6 is 4 root 6. So that's what we get in the numerator. And then in the denominator, we've got to FOIL this thing out, right? So 2 times 2 is 4. 2 times root 6 is 2 root 6. Negative root 6 times 2 is negative 2 root 6. And then negative times a positive is a negative. And then root 6 times root 6 is root 36. Okay, so now that simplifies. 8 plus 4 root 6 on the top. We'll leave that alone. But look, these 2 root 6's will cancel each other out. And we have 4 minus square root of 36 is 6. So we have 8 plus 4 over, 4 root 6 all over negative 2. So, a couple of things. One, you can't have a negative in the denominator, so we'd have to switch all those. But we can actually, the 8 and the 4 are both evenly divisible by negative 2. So let's divide both of those by negative 2. 8 divided by negative, here, how about let's rewrite this so that it makes a little bit more sense. So this is the same thing as 8 divided by negative 2 plus 4 root 6 divided by negative 2. 8 divided by negative 2 is 4. And then 4 divided by, negative 4. 4 divided by negative 2 is not positive, but negative 2 root 6. So that we have now rationalized the denominator. Okay, same idea over here. Got to multiply again, we want to change the sign in front of the root. So we got to multiply this by negative root 5 plus 3. We leave whatever's in front of the non-radical. We leave that one alone. We got negative root 5 plus 3 over here as well. So we're going to want to distribute this 2 through to the top. So that's negative 2 root 5. 2 times 3 is plus 6. The bottom negative times a positive is negative. Root 5 times root 5 is root 25. Root 5 times 3 is 3 root 5. 3 times negative root 5 is negative 3 root 5. And then 3 times 3 is 9. So on the top, we just have negative 2 root 5 plus 6. Right? And on the bottom, that's negative 5, 3 root 5, and negative 3 root 5. Cancel each other out. Negative 5 plus 9. So we get 2 root 5 plus 6 all over 4. Now, all of these can be evenly divided by 2. So we can get basically we can divide each of these by 2 and simplify it a little bit. So 2 root 5 over 2 is just our root 5. 6 divided by 2 is 3. And 4 divided by 2 is 2. So that's our simplified version. All right? Okay, that's all there is for division by surds. If you have any further questions, please feel free to ask in class. Thanks.